Hello, this is Mrs. Sargent, and this is Lesson 6.5, Types of Reactions, Synthesis, and Decomposition. So this is reaction types 2 and 3. So the first type of reaction that we're going to talk about is synthesis. Synthesis is a combination of two or more products to form one product. The general equation for this is when chemical A reacts with chemical B, you form chemical AB. Another way to think about this is Valentine's Day isn't too far down the road. So say all of your friends have dates or you really want to go to a dance or a party. And so you think about who is your crush, and then you determine how you are going to win that person over. And so you work up your best pickup line and you try it on your crush, and magically it works, and now two individuals become one couple. So the first reaction that we're going to look at here is we're going to watch a video on this for exploding bubbles. When hydrogen gas reacts with oxygen gas, we're going to form H2O. So we're going to count the number of atoms in our chemical equation. We have 2 hydrogen atoms, 2 oxygen atoms. In the reactants, 2 hydrogen atoms in the products, and 1 oxygen. So in order to balance this out, we're going to need to put a 2 in front of H2O. That's going to give us 4 hydrogen and 2 oxygen. Then we're going to put a 2 in front of hydrogen gas. 2 times 2 is 4. Now everything's equal. Go back and put a 1 in front of O2. So this video is going to show us exploding bubbles.
Using it as a fuel source, and there's this video that's going around with a guy who has salt water and he's hitting it with microwaves and lighting it on fire because he's separating the hydrogen and oxygen.
Right.
So I thought, why not bring you hydrogen and oxygen and kind of dispel some of the myths?
Okay.
Got it? All right, so put on your glasses. Good. All right, so here is a tub of soapy water. So you see the soap that's right over there?
Yep.
I had some before, but just a little bit for good measure. So there's our soap. And now I've got a balloon of just oxygen. Okay, so this is just pure oxygen.
Right.
All right, so we're going to bubble down just pure oxygen. Ooh. Good. All right, so what happens now, Becky, when we light pure oxygen on fire?
I don't know, Steve.
Here,
quite honestly,
the camera can't really see that, so here, dip your hands down in here for a second. Good. Good. Now scoop up some of the oxygen bubbles. Good, and so let's light them on fire. See? Nothing happens. See, oxygen is not explosive.
Right.
Oxygen helps support combustion, but by itself, it's not explosive. See how it burns just a little bit, right? Yeah, see, it's not bad at all.
Yeah.
So now, what if we did this? This balloon here, however, has 2 parts hydrogen.
Yeah.
1 part oxygen. So what will that make? What's 2 parts hydrogen, 1 part oxygen?
H2O.
See, that degree paid off.
Sure.
So this is perfect, all right? So now, see, I didn't tell you that. So now here, watch what we're going to do. Dip your hands down again, so make them, they're wet. Okay, so pull them back out. Now I'm going to make bubbles here, all right? So here's our bubbles. And what I want you to do is I'm going to ask you to scoop up some of those bubbles, all right? So it's okay, scoop up some of the bubbles. Good job. Hold them in your hand.
Yes.
Oh, wait, here, just take them off. Put on your earplugs. Would you do that?
Oh,
put on yeah, it's okay. So put on your, and they look so good, too.
Sorry, bro, I can't hear you anymore.
Okay, good. So now scoop up some bubbles. Good.
Okay.
Okay, good. So scoop. Oh, good. And so now we light them on fire. Isn't that amazing? See? So that's 2 parts hydrogen, 1 part. You want to do it again?
Yes.
Let's do it again. All right.
Please.
So this is 2 parts hydrogen.
Like
Phil, I forgot to tell you, cover your ears. All right. So 2 parts hydrogen, 1 part oxygen. So what we get is this tremendous release of energy, but it didn't hurt that bad, did it?
It didn't
hurt at all. Right? Do 2 parts hydrogen, 1 part. Isn't that amazing? It is.
My heart's going like a million miles an hour.
So that is our exploding bubbles. The next reaction that we're going to look at is magnesium oxide. So we have magnesium ribbon reacting with oxygen to form magnesium oxide. So in our reactants, we have 1 magnesium, we have 2 oxygen. In our products, we have 1 magnesium and 1 oxygen. So in order to balance this out, we need to put a 2 in front of magnesium oxide. It's going to give us 2 magnesium and 2 oxygen. Put a 2 in front of magnesium in the reactants, and that will give us 2. Everything's balanced, and we're going to put a 1 in front of oxygen. This is the second type of combustion reaction I was mentioning earlier in our last lesson. It does not have a hydrocarbon for the fuel. It has magnesium, but it's still burning in the presence of oxygen, and it's going to form magnesium oxide. So you can have a combustion reaction with a hydrocarbon, or you can have a synthesis combustion reaction where you have, in this case, a metal burning in the presence of oxygen to form one product. So here is a demonstration of burning magnesium ribbon.
Short video. I'll be burning magnesium ribbon. I place a piece of magnesium ribbon on a Bunsen burner and wait until it ignites.
So it burns really brightly. That's some of the energy that is also going to be released in the
Let's have a
synthesis
closer look at the reaction.
That is also a combustion reaction. And then we're going to write some synthesis reactions here. We have lithium reacting with bromine gas. So we're going to start with lithium. Anytime you have a metal by itself, you're just going to have one of them, and that's always going to be a solid. It's going to react with bromine gas, which is Br2 because it's a diatomic and it's a gas, and it's going to form lithium bromide. We know that it's going to be one lithium and one bromine because lithium is a 1+, and bromine is a 1-. So we only need one of those in order to balance it out for our chemical formula. And I believe that this is going to be a solid. So now we need to count the number of atoms. We have 1 lithium. We have 2 bromine in our reactants. In our products, we have 1 lithium, and we have 1 bromine. So in order to balance this out, we need to put a 2 in front of lithium bromide. That's going to give us 2 lithium and 2 bromine. And then we need to put a 2 in front of lithium to get our 2 there, and balances that out. And now we have a completely balanced chemical equation. In our next example, we have nitrogen gas. Nitrogen is a diatomic, so N2, reacting with hydrogen gas, which is H2 because it is also a diatomic, and it's going to form ammonia. Ammonia is one of those commonly named covalent compounds we talked about in Unit 4 with our ionic and covalent compounds. This is NH3. This is different than ammonium, which is our polyatomic. It has a different formula. The state of matter for this is going to be aqueous because it's going to be a solution. So then we're going to go through and we're going to count the number of atoms we have. We have 2 nitrogen and 2 hydrogen in our reactants. In our products, we have 1 nitrogen and we have 3 hydrogen. So now, in order to balance this out, we're going to put a 2 in front of NH3. It's going to give us 2 nitrogen and 6 hydrogen. So now nitrogen is balanced, hydrogen is unbalanced. We're going to put a 3 in front of hydrogen gas. 3 times 2 is 6. Now everything's going to be balanced. We're going to put a 1 in front of our nitrogen gas. So those are the synthesis reactions.
So inside here.
Sorry about this. I'm just gonna.
When nitrogen triiode.
Okay. So decomposition reactions is the next type that we're going to talk about. Decomposition, just like in biology, it's the breakdown. In chemistry, it's also the breakdown. It's going to break up one compound. So one compound, one reactant is going to break into 2 or more products. The general equation for this is when chemical AB decomposes, it's going to form chemical A and chemical B. We talked about synthesis is the couple getting together. In decomposition, maybe this is after Valentine's Day. You're like, man, this relationship is too much work, and so you just decide to break it off and be friends. And so the one couple splits up into two individuals. So the first demo that we're going to look at is elephant toothpaste. The reaction for this is when hydrogen peroxide decomposes, it's going to form water and oxygen gas. So we're going to count the number of atoms on each side. We have 2 hydrogen, 2 oxygen in our reactants. In our products, we have 2 hydrogen and 3 oxygen. So now, in order to balance this out, we're going to think about what is going to balance this out when our hydrogen are equal, but our oxygen are uneven, and we have, there's nothing we can multiply by 2 to get 3, and nothing we can multiply by 3 in order to get 2. But if we double our first one, it's going to give us 4 hydrogen and 4 oxygen. So then if we double water, that's going to give us our 4 hydrogen, 2 oxygen there plus 2 there is a total of 4. So now we have a video to show us the elephant toothpaste. Oh, and go ahead and put a 1 in front of O2.
So inside here, we happen to have hydrogen peroxide, a little bit of soap, and we have some food coloring. So we'll see if we can make some rainbow reaction. All right, you ready? Okay. All right, so here's what's going to happen. Our catalyst is going to get close here. We're going to dump it. We're going to go 3, 2, 1, and dump it in. Ready? 3, 2, 1, dump it in. Ready? Back up, back up. Ta-da! That's actually pretty cool. The problem is we don't know how to make it stop from here. They just keep going.
And it's going to go until the catalyst is used up, and then the reaction will stop once the catalyst is used up.
It's a pretty good thing if you think about it. They just keep going.
We're going to skip over this next one because you don't have that in your packet. And then we're going to just write some decomposition chemical equations. So we have zinc hydroxide. That's our reactant. Zinc is a transition metal, but we talked about that it's always going to have a 2+ charge. Hydroxide is OH, and it is a 1- charge. So our formula, we're going to crisscross the numbers from our charges. ZnOH2 decomposes, that's another place you can write in the yield arrow, into zinc oxide. So again, zinc is a 2+. And oxygen is going to be a 2-. So crisscross those, ZnO, and then we have water for our second product. So then we just need to balance this out. We have 1 zinc, we have 2 oxygen, and we have 2 hydrogen. In our products, we have 1 zinc, we have 2 oxygen, 1 here, 1 there, and 2 hydrogen. So this chemical equation is already balanced. We just need to put 1s in for our coefficients. And then in our last example, we have barium carbonate decomposing to form barium oxide and carbon dioxide. So barium is a 2+. Carbonate, the formula for that is CO3, and it's 2-. So our formula for barium carbonate is going to be BaCO3. Decomposing to form barium oxide. Barium is a 2+. Oxygen is a 2-. So again, we need 1 and 1, BaO. And then carbon dioxide, our formula for that is CO2. So then we're going to count up the number of atoms that we have. Barium, we have 1. Carbon, we have 1, and oxygen, we have 3. In our reactants, in our products, we have 1 barium, we have 1 carbon, and we have 1, 2, 3 oxygen. So this is balanced. We're going to go back and we're going to fill in with 1s. You need to take a look at the synthesis and decomposition practice problems. We are going to move on and we're going to talk about 2 more types of reactions next in our next lesson. I would make sure you take a look at combustion, synthesis, and decomposition at this point before we add in some more types and you have more things you have to remember in order to write those chemical equations. Thanks for stopping by. Come in and ask me questions if you have any, and have a great day.